three parts of an atom: protons, neutrons, and electrons. Protons have a positive charge, and that's easy to remember because P and positive are the same letter. Protons are positive. That can get you in trouble when you talk about neutrons, though. If you get one wrong, neutrons almost sounds like negative charged. No. Neutrons have no charge. N stands for no charge. They're neutral. Yes. Okay. And I'll explain why, but put in parentheses glue next to neutron, because we're going to talk about, we'll kind of review electrostatic charges from last year. Weird looks on your faces. You guys, I guess now is maybe a good time, but you guys remember last year, what happens if you have a positive and a positive charge next to each other? They repel. And in opposites, they attract, right? So positive and negative attract, positive, positive repel. And you're the same with magnetism. If you've got a north pole and a south pole, they're opposites, so they attract. But if I have a north pole and north pole, they repel.
So our Earth would get 20 parts.
So it's all stuff from last year that we already know, but we did a lot of this stuff online, so it's kind of hit and miss. Some of you are like, yeah, I didn't really pay much attention to that lesson. I just took the quiz or whatever it was and moved on. Okay. Now, the protons and neutrons are found in the nucleus of the atom. And just like with atoms last year, the nucleus is in the center. Nucleus is going to be in the center of the atom. And the electrons, these are going to be found in shells around the outside of the atom. In shells around atom. Electrons have a negative charge. Positive, negative charge. So protons and electrons, they're going to be attracted to each other. But a proton and a proton, they're going to want to repel each other. And think of as neutrons as being glue, and we'll explain that in a second. Now, atoms are made out of matter. That means they have mass. That means they have weight. But as we know, atoms are super, 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 super tiny. So we don't want to measure these in grams or kilograms, right? We'd have a number that's like 0.0000000000000000000. You get the idea. A lot of zeros, grams. And who wants to write that down? Not me. Okay. So we've got a new unit that we use when we are actually measuring the size of an atom, and they're called atomic mass units, or AMU for short. Okay. Now, measuring the mass of an atom is actually really easy. Protons weigh 1 AMU. Neutrons weigh 1 AMU. And electrons weigh 0 AMU. So write this down next to your protons, neutrons, electrons, and we're going to practice weighing some atoms, so to speak. But it's pretty easy.
Wait, but aren't atoms like really small?
Yes. Yes, they are. Okay. Technically, electrons don't weigh nothing. They weigh like 0.001 AMU. That's close enough to 0 that I think for 8th grade math, can we just agree and round that to 0? Anybody upset? And technically, neutrons weigh about 1.001. But to make the math easier, can we just round that to 1 and be happy? Thank you. So, the difference of an electron, it's like if I stepped on a scale and I weighed myself, I weigh 185 pounds, all right? Now, put this piece of paper in my hand. Do I weigh more?
Yeah.
I do, but it's a pretty small amount. We can kind of just assume that it doesn't weigh anything. It does. If I weighed it on the scale, it probably weighs a couple grams. But it's close enough to 0 that we're not going to count it. So, whenever you're looking at a diagram, for example, here's a diagram of lithium over here.
Whoa. You want us to write that down?
listen first, but you'll be drawing some of these too. Let me just talk you through the process here. The nucleus is in the center, and what I've done is maybe I should have made a key, but I'm drawing my protons blue. For you, because you're out of pencil or just a pen, if I was drawing a proton, I'd probably make a circle with a plus in it. The plus tells me that it's the proton because they have a positive charge. I'd make my neutrons either an open circle, or maybe I could color it in. Maybe make that a neutron. Okay. And I'd make my electrons a little e with a negative sign on it. Okay, that's kind of my key. Now, you've all got a periodic table, and we're going to talk through the periodic table here real quick. And I've got kind of some definitions over there as well. But first, I want to just talk about atomic mass units and how much an atom weighs. This atom weighs 7.
7 what?
AMUs, atomic mass units. How do I find that number?
Add them up.
I've got to count how many protons and neutrons there are in the nucleus. So I've got 1, 2, 3, 4 neutrons and 1, 2, 3 neutrons. I add those up. 4 plus 3 equals 7. You'll have the same number of electrons as you do protons. So since I had 3 protons, 3 blue ones, I'll have 3 electrons whizzing around the outside. But they don't weigh anything. I don't have to count them. With me so far? Just quick self-check. I'm going to draw an atom of, well, how much would this atom here weigh if I have a, and I've got 2 electrons whizzing around. How much does this weigh?
4.
Weighs 4. Why?
Because there's 4 things in the nucleus.
4 things in the nucleus. Okay? We call this the atomic mass, or how much it weighs. Okay. So, on your notes, add atomic mass. That is the number of protons and neutrons in the nucleus. So the number of protons and neutrons in the nucleus. The other number I'll have you write down on your notes is the atomic number. Bill Nye video repeated this 1,000 times so it sticks, like the number of protons in the nucleus. The number of protons in the nucleus. What is that? The atomic number. The number of protons in the nucleus? Yep, the number of protons in the nucleus. Okay. This is a very special number because it will tell you the identity of the atom. And this is where we're going to flip to our periodic table here in a second. It turns out that every single atom in the universe that has 1 proton is hydrogen. Okay? It's how you know what kind of atom it is. You look how many protons it's got, and it'll tell you what kind of atom it is. Okay? So, what I've done here is I've drawn one of the boxes from the periodic table here. If you look at your periodic table in the upper left-hand corner, okay, this is the box you see. It's got a 1 in the upper left-hand corner. It's got a 1, I think it's probably got a 1.008 or something like that on the bottom here. Okay, this is the mass. I'll talk about why it's 0.008 probably tomorrow. But basically that rounds to 1, right? So what that says is, if I was to draw this atom, it's got 1 proton, that's what the atomic number tells us. So I draw 1 proton in the nucleus, and it weighs 1. So there can't be any neutrons here. If I had a neutron there, how much would it weigh? 2. If I had 2 neutrons there, it would weigh 3. But it doesn't. I know that because it weighs 1. Christian?
What about like the one that has like 266?
Okay, 266 has how many protons?
266.
Do I want to draw that one?
Yes.
So I guarantee there won't be one of those on the test because I don't want to draw 266 protons plus another 300 neutrons plus all the different electrons that are out there. It is a very complicated atom. So we will probably stick, I'd say we probably won't go past 20. Just because it does get complicated and really messy to draw all those out. Okay. So, take a look on the upper right-hand corner and you'll see helium. Draw this box here, and what I want you to do, and I'm going to come around and check, I want to see if you can draw a helium atom. Draw a helium atom on your piece of paper, on your notes real quick. Okay? We're going to draw helium. This is what hydrogen looks like. This is what number 3, lithium, looks like. Can you figure out what helium looks like? No. Why not? Do you know how many protons there are?
2 trillion.
Can you figure out how many neutrons there are?
Yes.
How?
By subtracting 4 and 2.
Subtract 4 and 2. I know that there are 4 things in the nucleus. 2 of them are protons. So how many of them have to be neutrons? 2 plus 2 is 4. I'm going to have 4 things in the nucleus. How many electrons are there going to be whizzing around the outside?
26.
No.
More than 1, probably.
Same number of protons there are.
Oh.
There is going to be 2.
Mr. Mahoney, I drew it.
Let's see it. Let me put my mask on.
Come on, Mahoney, you
I
gotta
know.
know this.
Looks good. I don't see it. Come on, Montgomery.
I did it,
Which?
Mr.
Okay, so 2 of those are protons, and 2 of those are okay. Good. Not done yet. Not done yet. Good. Come on.
Come on, Jason.
I know how many protons there are.
Hi, Mr. Shellman.
Same number of protons and electrons. It'll balance. So remember, and this is, this is something that at first is pretty common. You draw with too many electrons, well, it's going to have a charge. So most atoms are balanced. If there are 2 protons, 2 positive charges, you need 2 electrons to balance it. If you put 4 electrons, it'll have a negative charge. It'll be called an ion, and those exist. We're just not talking about them today. Okay? So, this is what you should have drawn. 2 protons in the nucleus. 2 neutrons in the nucleus. Now, you'll remember over there I mentioned that the neutrons are like glue. If there were no neutrons in the nucleus, do these 2 positively charged protons want to stay next to each other?
No.
No, they repel.
Get it before.
Okay? They want to repel, they want to get a divorce. So, it's definitely way simplifying things, just calling them glue. It's not exactly a perfect analogy. But if you think of them like, if I've got more than 1 proton, I'm going to need some neutrons to like hold the nucleus together. And then there are shells where the electrons are going to be whizzing around the outside. It has 2 protons, so it's going to have 2 electrons in it. This is what your diagram should look like. Now, if you take a look at your periodic table, you'll see it is numbered just like a book. In the upper left-hand corner, there's hydrogen, and it has 1 proton. Then you go all the way across to the right-hand side, and there's helium, has 2. Then you go to the next line down all the way to the left, just like you're reading a book from left to right. What's the next atom you see?
Lithium.
Lithium, and the next to lithium is
Beryllium.
barium, and then boron, then carbon, nitrogen, oxygen, and you're going 5, 6, 7, 8, goes all the way along until you get to the end, then you keep going. So it's a numbered list going from left to right. What do those numbers tell us?
How many protons?
How many protons there are in the nucleus. What's the number on the bottom tell us?
How much it weighs.
How much it weighs. It's its mass. So we can figure out how many neutrons the atom has by doing a little bit of math. A little subtraction. Okay, Christian?
How many AMUs does it take to actually start making, like you can actually start feeling the weight of it?
Oh, I would say trillions.
Oh.
Oh, wow, you did.
I was just wondering.
Yeah, I mean, one thing I forgot to mention. Now, these diagrams are definitely not to scale, right? Remember Bill Nye was saying how atoms are mostly empty space? If we had a proton that was about, if we zoomed in on the proton that was about this big, you probably wouldn't be able to see the electron. It'd be so small, and it would be out there probably close to the football field whizzing around. And everything in between is literally nothing. There's no air, there's no nothing in between it. And so you might recall, well, if this is almost all empty space and there's this little tiny electron whizzing around, why does an atom act like a solid? It's moving so fast, kind of like a propeller on an airplane, right? You can't put your hand through a propeller on the airplane. It's mostly empty space, but that electron is whizzing around in all directions so fast it acts like a solid. That's kind of hard to get your mind around, but that's something that we've got to get past. Okay? So, what I want you to do real quick is flip over your periodic table, and I'm going to have you draw. I'm going to draw right here what I want you to draw.
Like really big or really small?
Make it big because it's just going to be one thing. Eventually, we'll use skittles to represent your protons and your neutrons and electrons, and you're just going to draw them on that and set them on there. Well, I don't want to eat them after you touched them, right? You can eat whichever the ones I touch if you want. Yeah.
How many subscribers do you have? Like 14.
I don't know. Subscribers? Oh, you mean like on YouTube? Oh, maybe not even that many. One. All right. Okay, I want you to draw a circle that and label it nucleus in the center. Okay, this is where you're going to draw your protons and your neutrons.
Is this on our notes on the back?
On the back of the periodic table. Okay, then I want you to draw a circle. You know, give yourself about an inch. You're going to draw 3 circles around it and make it fit. Of course, mine is already off my board, but whatever. 3 circles. We're not going to go farther than 3 circles. 1, 2, whoa.
Mine looks like a donut.
3 circles. Okay, we're going to talk about electrons. Oh. Let me move this back over to where it can be seen. Okay, for electrons. Electrons are always looking for a soulmate. Okay, if they had emotions, they always like to be paired up. And that's important when we talk about to which atoms will combine in what we call bond to other atoms and form new things. What's happening is one atom, that electrons in the outside are trying to find other atoms that they can pair up with. So the nucleus here, inside nucleus, write P equals and N equals. That way you don't have to draw out like 26 protons and 35 neutrons or whatever it is. You can just write the number. It's easier for me to come around and grade them. The first shell can hold a maximum of 2 electrons. It's the closest one to the nucleus, and once it's got 2 electrons in it, it's full. And then the next electrons will be moved farther away from the nucleus into the second shell. This shell can hold 8.
Wow. That's a lot.
Okay. There is an equation, 2n squared, that you can figure that out. This next shell will actually hold 18.
MC squared.
But what happens, and we want to keep this pretty simple because we're just in 8th grade, they don't always pair up after 8. It's not quite as easy and simple, so we probably won't use more than 8 here. Technically, it'll hold 18 before it goes to the next shell, which holds a lot more. But after 8, it won't wait until this shell is filled before it'll start filling up the next shell. And that's something when you're in college you can sort out and figure out. So we'll probably actually 18 number. What is number 18 on the periodic table?
I have no idea.
I probably won't give you any examples past that.
Argon.
Argon. Argon's probably the last one that we'll do examples here with in 8th grade.
Sounds like a transformer.
It does. In fact, you'll notice there's a lot of weird sounding ones. All the elements on the periodic table have a name and a symbol. More often we'll write down the symbol. Some of the symbols are really easy, like H for hydrogen and HE for helium. Okay. Can anybody find gold on the periodic table?
39.
It's really heavy with this metal.
AU.
AU stands for gold. Now here's something I'm not going to make you memorize the symbols for the elements. That's why we have periodic tables.
Yeah.
Okay?
79.
79 AU. Right next to it is AG. What's AG?
Mercury.
HG?
AG.
Silver.
Silver.
Oh.
Oh.
Okay? It's like Latin for whatever they used to call silver. It's an abbreviation of the Latin word.
Oh, it's
Okay?
AG.
There's some that are, K. Find K on there. What's K stand for?
Krypton. Potassium.
Potassium. Krypton is Kr. It's on there.
That's an actual thing.
It is. It's an element. Okay?
DC ran out of
I ran out of ideas and had to steal from the periodic table. All right. So this is what I want you to do. On your empty thing here, I want you to draw a picture of an oxygen atom. So look over on the periodic table. You'll see the little box, right? 8O says oxygen. You've got a 16 down. It's rounded. It's bigger than 16 point something. But it rounds to 16. It's what?
15.99.
Okay, 15.99. It rounds to 16.
Yeah, E. Felt like E.
Okay? Just shouldn't take you very long. All you got to do is tell me how many protons that atom has, how many neutrons that atom has, and draw the electrons where they would go on the shells. Way too many. Okay,
I think finished.
Mr. Mahoney.
way too many electrons. Okay.
CJ has about 24.
So this is where, most of you did okay on the protons and neutrons, and then I glossed over how many electrons there are, because almost everybody got the next part wrong. So this is what you would write down. Protons. I know there are 8 protons, because that's the atomic number. Okay? Finding the number of neutrons, I've got to do a little bit of math.
Perfect.
I know there's a total. Ethan, knock it off. I know there's a total of 16. So if I've got 8 protons, how many more neutrons makes it equal 16? 8 plus 8 is 16. Now, the number of protons and the number of electrons is going to be the same. So 8. There's 8 protons. So I need 8 electrons. So if I'm drawing that, I know I can put 2 of them in the first shell. There's 1, 2. I started out with 8. I've put 2 of them in. I've got 6 left over, right? I put 2 in. Now I got to put 6 in this next shell.
Okay, so I got a race.
But I
Okay.
had it, and he says too many.
Right, it looked like too many. My mistake. If you got it right, you're fine. Okay?
I gotta write this
Time to go.
Is it time to go? Oh, I got another. I want you to try one more real
You
quick.
got in a few seconds.
Okay? Boron. Find boron on it. It's at the top.